Lesson 3, position, speed, and direction. So we're going to use signed numbers to represent movement. Today's I can multiply a positive number with a negative number. I can use rational numbers to represent speed and direction. So today's date, your I cans, page number. Don't forget to put it in your table of contents, and you are ready to go, just like they are. All right, let's review distance, rate, and time. So you should remember some problems we did with distance, rate, time. Rate, another term for that would be speed, that we've used more regularly. So remember that distance is equal to the rate or the speed times time. Okay. So we're going to think about these three here. We're going to go over them in just a second. An airplane moves at a constant rate of 120 miles per hour for 3 hours. How far did it go? What about a train that moves at a constant speed and travels 6 miles in 4 minutes? What is its speed in miles per minute? A car moves at a constant speed of 50 miles per hour. How long does it take the car to go 200 miles? Right. So looking at the plane going 120 miles per hour for 3 hours, how far did it go? Well, we know we have 3 hours, right? And if we take that rate of 120 times the time of 3 hours, that gives us 360 miles. Here we have the train going 6 miles in 4 minutes. Our question is, what is its speed? What is its rate? Yeah, so we have to take the distance and divide it by time. So we get the rate is equal to distance divided by time. So we take 6 divided by 4. 4 goes in 6 one time. If that 4 went into 6 one time, that would give us 2 left over. Bring down the 0. 4 goes into that 25 times. So the rate of speed is 1.5 miles per minute. Miles per minute. Okay, go to the last one here. So a car goes 50 miles per hour. How long does it take to go, or for the car to go 200 miles? So we know the distance is 200 miles. How do we find the time? Well, we're going to have to take that distance and divide it by the rate. So if we take 200 and we divide it by 50, we get 4 hours. Okay, quick little review. So you might want to jot these down to help you if you can't remember. For distance, that's rate times the time. For the rate, you take the distance divided by the time. So that's how you get your miles per hour. To find the time that has passed, you take the distance and divide it by the rate or the speed. Okay, let's dig into some other ones here. So this is going to work with moving left or right. So we've seen before that you can kind of pick a location to represent 0. And then depending on which side of that you're talking about, you're either negative or positive. And that's what we're going to do in this activity. So what you're going to do is we'll start at 0 every time. And then you're going to move either right or left for a certain number of units per second and then it'll tell you how many seconds, and then we have to figure out what that position is and the expression that goes with it. Okay? All right, let's make this a little bit better. All right, that should work a little bit better. So the example here is we started at 0. We moved 5 units per second and went 3 seconds. So that means that our ending point would have been at 15, right? And we did that by taking 0 plus the 5 times the 3, and that got us where we need to go. What about if we move to the left for 4 seconds, or 4 units per second, and then we move for 6 seconds? That's 24, right? Because 6 times 4 is 24. But we're moving to the left, so yeah, this should be a negative. And we know that because it should be 0 minus 4, because we're going to the left, times 6. All right, go ahead and work out these other ones. Okay, so should have those figured out by now. Let's go ahead and go through them. So, moving to the right at 2 units per second for 8 seconds. Yeah, that's going to be 16, because we're going to go start at 0, and we're going to go positive 2 times 8. Same thing here, right? This is positive. This is going to be a positive 12, right? Because we're going starting at 0, and then we're adding to the 0 6 units every second, and we're moving 2 seconds. Then here we're talking about moving to the left. Yeah, so this is going to be 0 minus the 1 1/10 times 5. Well, 1 1/10 times 5 is 5 5/10. And we're moving to the left, and that was a minus, so it should be a negative 5 5/10. This looks prettier. But what do you notice about the direction on these? Yeah, just like before, going to the left of 0 gave us a negative number. Going to the right of 0 gave us a positive number. So subtracting a positive is the same as adding a negative. So we could write the a single expression for all of these as just position plus whatever the velocity times time is. And that velocity, remember, in some of those was negative because it was moving to the left. And still, remember that adding a negative is the same as just subtracting a whole number, right? So we could leave it like this, but then we know that velocity could be either positive, which we don't have to do anything to add a sign to, or it could be negative, and that at the end, we're going to make this, your answer is going to end up being negative for these two together. All right, let's do one more thing here. So we can talk about speed in a direction by calling it velocity. Remember, speed and direction together make velocity, and using a signed number to help us understand which direction we're going. So in this representation, we're going to talk about moving to the west as a negative number, moving to the east as a positive number. So we have a traffic safety engineer studying travel patterns along a highway, sets up a camera and recorded the speed and direction of cars and trucks that passed by the camera. The positions to the east of the camera are positive, and the ones to the west are negative. All right. So what do we get with some of these results? Okay, so they gave us the example of 25 meters per second, positive, so that means it's going east, 10 seconds. It went 250 meters, positive. And that's taking 25 times 10 gives you 250. What about here? Yeah, we have a negative 20 velocity, so that means that they're going west in this example. We're going to multiply it by 30 seconds, and that'll give us a negative 600 meters. So that means it's 600 meters to the west. What about positive 32 meters per second, 40 seconds? Yeah, so we're going to have 32 times the 40. It's going to give us a positive 1,280, right? How do I know that that's correct? Well, again, positive number means we're going to the east, times the 40 gives me 1,280. 40 times 2 is 80. 30 times 40 is 1,200. All right, what about here? It's going to end up negative, correct? Because we're going east, so that should give us a negative number. So we have negative 35 times positive 20. That'll give us, yeah, 700, negative 700 meters. What about positive 28 meters per second after 0 seconds? Yeah, we know that that is, yep, 0. Neither positive nor negative because it's just 0. So let's think about this. If we multiply two net positive numbers, is the answer positive or negative? Yeah, it's positive every time, right? Look at our previous examples. What about if we multiplied a positive and a negative? What happened? Yeah, it's negative each time. And that makes sense because think about it. Multiplication is just repeated addition, right? So if you're talking about adding negative 20 to itself 30 times, it stands to reason that if you're adding negative 20 plus negative 20 plus negative 20, keep going until you end up getting all those negative 20s, that the answer is going to be negative 600. So whenever you multiply a positive by a negative, you always end up with a negative. Positive times a positive is always positive. All right, let's do a little rundown here. So sign numbers can also represent speed in opposite directions. This is velocity. Remember, velocity is speed and direction. Positive number multiplied by a positive number gets a positive product. Negative number times a negative or a positive number gets a negative product. So how can we represent a position to left or right of a starting point without using words? Yeah, positive numbers are to the right of that starting point. Negative is to the left. So just using that negative or positive tells you which way to turn on it. How can we represent how fast something is moving to the left or the right of the starting point? What do we talk about with speed with direction? Yep, it's velocity or velocity. What kind of number do you get when you multiply a positive by a positive? Yep, positive. And last thing here, what do you get when you multiply a negative by a positive? Yeah, you get a negative. All right. So I think we've gotten everything in. Hey, thanks for watching.